So here's the code. It's if you open up the terminal, it'll actually show you what mode it's on, what's saved, and it'll show the power. If it's on mode 0, which is a custom, it'll show you the values of the R, G, and B.
Wow, and so take a look. Kevin's done a good job adapting some of John's code and attributing it to him, and even trying to keep some format together.
Nice.
That's a great project, Kevin. I'm really impressed.
Thank you. I've 3D printed all of these pieces, and they use snap connectors, so if something goes wrong inside, you can just snap it all apart. So they're all poly panels, so that you can separate them. And let's see the back.
Any questions for Kevin while he gets this ready?
Oh, cool.
Wow, send him some filament.
Not a question, but I appreciate all the features you put into the remote control menu system you did. I would appreciate using something like that.
Yeah, the menu system was actually based off of the 6th program from last week.
Good deal. Good use of it.
Yeah, Stephanie's got some artwork at Parallax that has some control on it as well. Well, great job, Kevin. And so if somebody would like to sponsor Kevin with a Fly Sky RC unit, I'm happy to accept your money, because I'll be sending him mine, so he has one to work with next week when Johnny Mac shows us how this works, because we know that he can put it to use. So great work, Kevin. Keep bringing us more inspiration.
Thank you.
Okay, I'm just switching over to the presentation now, and we'll get started. Thanks everybody for joining us. May 5th today, 1 p.m. Can you believe it's been almost a year that we've been doing P2 live forums? The time goes by so quick. So pretty exciting. In some ways, a lot has occurred. Today's topic is documentation, and we have Jeff leading with Stephanie supporting him. So before we get to that, let's just talk briefly about the next couple of weeks. As mentioned a minute ago, next week, Johnny Mac is going to show us how to interface this little Hollywood favorite for human to whatever you want to control. So spoke with him this morning. He's already ready to go. And I'm sure we'll be in for some fun surprises. And by the way, we're now streaming on YouTube concurrent with the Zoom. So if you don't get registered, you can just go to our YouTube channel and watch us there. In 2 weeks, we have Gavin Garner coming to talk about his use of the P2 in his mechatronics class and the trainers that he built and what he demands out of his students, which is really interesting. This will be very, very informative, because he's been with us for 20 years. He learned on a basic stamp too. So look forward to that. In 2 weeks, we'll try to round up some more educators to join us for that presentation. And then we'll probably take a break the last week of May. We have to do an inventory count at Parallax, and unless somebody else wants to run the P2 live forum, I know I'll be pretty busy there. Coming up in June, and we have a lot of voids here in these dates too. So if there's anything you want to talk about, just let me know. It does not have to be formal by any means. It doesn't have to be a big topic showcase like this, like we do in Hollywood, but it could just be your own style, your own speed. So just let me know if there's anything you want to be sharing. In June, the first presentation we'll have would be this one from Johnny Mack, and we're just going to create and share an object for this very popular sensor, which is used a lot with the Propeller monitoring stations, the BME 680. So get yours. We have them in stock. Trying to give you enough lead time here, so if you want to get some parts, you could do that. And then we're going to move into GPS. We need to have a P2 GPS module, and this is also our favorite. The SIM33 EAU, which we just have trouble keeping in stock. So at the moment we're out, but you can go and add yourself to the wait list if you want to pick one of those up. And we also have a click module that has the same on it, I believe. So check that out. Then moving into summertime, here's a summerish type project that I've been working on for an eternity and don't really go anywhere because of my day job. But this time I'm determined to get something done. I plan on interfacing with John's help, several objects he's written, so I can get up to speed and share something myself like Kevin has done. And I will control this boat. This is a unmanned surface vehicle that I've run on Lake Tahoe to collect some water temperature samples. And I'll use the XB to send back its location. And I'll interface GPS module, and then I'll keep it under radio control too. So look for that. And I've seen a lot of action on the P2 forums online around this particular project. And you're looking at an in-progress cube that someone has printed up, and they've got the panels, and we now have these panels in stock. And the page is up so you can order them. We buy them 100 a time. So thanks, Stephen, for getting us going here, by the way.
Still working on it.
Yeah, your bug hunts are amazing. The forum thread is just exploding as people are trying to use the code now.
In case you're wondering, the red and the amber should not be on top of each other right there on that top surface.
This is in progress.
We'll get that worked out.
Yeah, it's looking great, and we're doing big things here.
It's
and also,
amazing. Yeah, go ahead.
I don't know if Team UK is around today or not, but oh, I see one of them. Just checking in to see if we can actually put some of these boards into production with some cool video game arcade cases that Coley's making. You don't have to pipe in now, Baggers or Coley, if you're here, but
yep,
just
I'm here.
Okay. How's Coley doing with this?
He's doing well. The actual cab is looking really good, but I think he's been a bit run down with work, and he had the his second jab the other day, so well, about 2 weeks ago. So that might have helped with him being run down. So he's just going to have a couple of days off for the moment.
Good.
And let's see if I can find any of the pictures he has sent.
And yeah, I'll stop share when you're ready. Just tell me.
Yep.
And there's no schedule for this either, as you guys know.
Yep.
Parallax is not one to set schedules ourselves.
No worries.
Okay, so when you have that ready, just holler. And the hoverboard motors. So Chip spoke about these a few weeks ago, and we've preemptively ordered 100 units. So these are coming, and we're building a bearing block to hold them. So maybe the hardware and the motors and the electronics will all converge, and we'll have a new robot drive control system, a modernized version. These have been very popular through Parallax in the past, not this particular wheel, but our motor mountain wheel kit for mid-size robots. So we're looking forward to having what we all think will be just the best system possible.
Does this mean we're on our way to a possible two-wheeled self-balancing?
Certainly in the cards here, yep. Would not have been easy to do with the previous motor, the encoder resolution and all the slop.
How fun.
And if you spend money right now, you get a silly string trap kit from Parallax, any order over $150. And what's in here that's cool? Well, you'll get a couple cans of this goofy string, and you'll get a laser ping sensor and a servo, and the parts if you want to put it together, or you can just repurpose this any way you want. Oh, and the Eternal cable, which we're still waiting for, so we could drive servos from the Johnny Mac from high current USB, is finally coming, we've been told.
I've
Okay,
got the
so.
X ready if you.
Oh, okay, great. I'll stop share.
Okay.
All to you. Good attendance today, by the way. Everyone's interested in something.
Right, can you see that?
Oh, yeah.
Nice.
That's a CAD 3D render.
That looks
That's
cool.
roughly what it'll look like.
Yeah, that looks great.
No. Press the wrong button. And that's the way. You've got the marquee up there, which we'll be able to have plexiglass or something so you can put an image on top of it. And this is just to help with the to support the joystick, so when you're waggling it, it won't rock too much. But it's nice and sturdy, and as you can see, it's taking shape. I have got that's one of his first laser cuts with it.
So we're looking at Baltic birch, like maybe what we'd call 1/8 inch.
Yeah, this one is going to be the single unit because it's got 8 buttons and a joystick. So, you know, for when we do more arcade games. I have been working on a Z80 emulator as well. I've got, I think there's one bug in it somewhere in one of the instructions, but a few of the games work. I've got my Pac-Manic Miner. Oh, it's my dog. Sorry, someone's walked outside. Walked past outside. Oi, oi, out of there. It's in the window. And I'll close the door. Right. So yeah, I've got one instruction that I need to fix, and then I should be able to start making some Z80 arcade games like Pac-Man and Galaxians and stuff like that. But yeah.
You have that artwork handy too. Maybe some people would like to see that who've not.
Anyway.
The artwork?
That goes on the cabinet.
Hang on the cabinet?
Yes.
Not yet, no.
Okay, it's really neat. Well, we'll show it at a future time.
Hey, what's the state of the Z80 emulation? I think I saw some talk on the forum about that.
Where's the Z80 is, well, the one on the forum's a different one. I think someone else is doing that one, but the one I'm doing is really close. I think I'm one instruction wrong somewhere. I think it's probably a flag or something, but it's like about 1700 instructions to emulate. So
how big did it wind up being?
It's not that much over a cog. There's just a little bit of stuff outside the cog that's running, and the other bit of stuff outside the cog is the pointers to all the instructions. But yeah, other than that, it's doing well.
I'm forgetting did you use XByte on that?
No, I didn't. The reason I didn't use XByte on that one was because it'd probably speed it up, but with it being Z80 and thinking ahead, because I know a lot of the games and how they work and the bank memory in, so I needed to have access to the read and write of the RAM, or some of the arcade games have to be able to read a 1K chunk all from the same byte, like a joystick port or something, but it can address any area in 16K. So I wanted to be able to call a function to read a byte from RAM or to write a byte to RAM.
With some filtration.
Yeah. So it'd have been, you could do it with Xcode, but you'd have to work around it because the call will cancel the byte skip, won't it, as well? So.
Okay.
Yeah.
Thanks, Jim. And
No worries.
wanted to be sure these two guys had a chance to talk because Jim is staying up very late with a dog that's going to wake up the rest of his house.
That's not my dog. That.
Your washing machine walking away.
No, that's not here. That's somewhere else.
Okay, just a minute. I'll mute the offending appliance.
Yeah, not me.
Okay, I found it.
Okay.
Thanks, everybody. All right. So today we'll turn this over to Jeff. Those of you who don't know Jeff's been with Parallax, I think, since 1996. And he came in the office. How long, Jeff?
Yeah, that's correct. 1996. I came in the office in 95 to buy a Basic Stamp 2.
Yeah, and then
Basic Stamp 1.
You returned in tech support and then you never left. And
That's
so
right.
now all of our software is created by you, just about, and so much documentation too. So Jeff is going to share where he is with documentation and what we're doing as a company. And he's joined also by Stephanie. And Stephanie's been with us at least 15 years, I think, and as product and documentation manager. She's our editor. She's a question generator, solution provider, and makes us look good. And she's been keeping the weekly meetings going too for our documentation team so that we can have these reports. So Jeff, over to you.
Okay. Hello, everybody. Thank you for joining us today. I'm happy to be here and happy to have something to share with you. It's been a while. I just clicked away from my Zoom view. I'm going to start sharing my screen here. Looks like the right one. Okay, everybody should see our agenda for today.
Yep.
So what I'm going to do is talk about what we're doing, kind of paint a little picture of behind the scenes, followed by the releases that we're going to release today or that we have released just before the meeting and where to find those, discuss some participation points for all of you, and talk about some future releases and our distribution plans, or like the format of those plans. So to begin with, back in, I think it was early March, maybe late February, we really, it was Stephanie, Michael, and I really seriously got going talking about, kind of discussing and digesting the documentation, the core documentation that that Chip provided, and also where we need to be. And of course, we had an example with the Propeller 1, but we wanted to not necessarily follow exactly the same recipe if we find something better. So there were plenty of discussions about that, and we started, I started going through, actually, I guess all of us started going through a copy of Chip's Silicon doc and kind of trying to get our minds around it. There's a lot of material there, and it becomes kind of difficult to get to the 10,000 foot view of it all, to figure out how to organize things, to make other documents like a data sheet and a Propeller manual. So that's one of my big tasks. And at around the same time, Chip and Michael began extensively testing the Propeller 2 under various strains, current voltage and temperature. And that was really important because we needed, of course, to have a lot of that data for the data sheet so that everybody can see just how far they can go with the propeller in actual practical applications. And so what we did with that is initially we actually created the spec sheet, which many of you have probably seen. You can get it from, let's see here. If you go to our main website, Propeller 2 documentation, there's the spec sheet right here that you can download. And it looks like this. And that was intended to be a single page, which that's what it ended up being, a single page document that is, you know, just a really good introduction level view for anybody not familiar with the propeller. So it's what we expect a lot of people to look at initially when they're maybe reviewing or checking out a number of other devices from various distributors. So some of that test data that was done was instrumental in producing this document because we had to make sure that we got those figures correct. Okay, so then let's see, where did I leave off? So then they continued working on that data for the data sheet, or working on those tests. And meanwhile, I switched over to working on or creating the propeller manual. Hold on a second, one of my, trying to get this thing slid out of my way. The Zoom controls tend to get in the way sometimes. Okay, so here's just a quick, this isn't really the point of this meeting, but I just wanted to show you that I started working on kind of the skeleton of the propeller manual from some of the data that was from CHIPS documentation. This is something that we intend to release starting in June with a number of further releases after that. And along the way, started asking Chip a lot of questions, things that I couldn't find in the core documentation. So it was very productive and then naturally led into creating the data sheet. And you can see here, this is where I left off, where I started categorizing the various spin 2 commands, getting ready to work on the spin 2 language reference. Okay, and so most recently what we've been working on is the Propeller data sheet, the Propeller 2 data sheet. So just to give you an idea here, remember I showed you the spec sheet, that's just a single page document. The data sheet we view as a kind of a stepping stone into even deeper material. So we intend the spec sheet's just a single page, the data sheet should be, you know, a few dozen pages, and then the P2 manual itself, there's so much material to cover, so many features of the P2, I'm really predicting it's going to be 600 pages plus. The P1 manual, I believe, is just short of 400 pages, and that's with an index. I think we'll easily hit like 600, and I'm not trying to make it that big. It's just there's a lot to say and a lot of detail to discover and experiment with and demonstrate along the way. So today, what we have is the data sheet that we released, the very first version of it here in PDF form. You can get to it from that same Propeller 2 documentation page. It's available in PDF form, looks like this. And this is, you know, by no means complete. It's just the first edition. We'll be releasing or doing many updates here over the next couple of months. But I'll just point out a couple of things in here that are kind of nice. So there's the large pinout diagram and then a couple of examples of connection diagrams to give people a good idea about just what it takes to get this propeller going. So some minimal connections, and we have Michael to thank for the diagrams. By the way, he's been working really hard on those. And then here's with a single boot memory, and then a dual boot memory. And at the bottom of each of these, it describes what some of the things that you need to know or make sure are connected properly to make that happen. Okay, and I'm actually going to switch over, I think up, I forget where it is, maybe Stephanie can jump in here, but there's, in the document, I believe that there's a link to a live document, but it's also on this community page right down here, or excuse me, this documentation page right down here. So I'm going to go ahead and open that up. This is the document that everybody can comment on, the current P2 data sheet. So we encourage everybody to come in here and note things that I know that there's a lot of material that we've left out currently. So don't focus on that so much, but focus on what is there, and if there's something wrong or maybe misleading or you don't quite understand it, those are the kinds of things that we want to know at this point. Later on, when it gets closer to June, if you see stuff that you think is really missing, please, start beating me over the head with comments about that. I'd be happy to go through and try to address that stuff. So this is available for anybody going forward to go through and comment away. We will address those as we go. We're going to continue working on this for the the foreseeable next couple of months. I expect that there'll be many releases of PDFs here in that time, probably maybe as often as once a week. We will typically do it on a like a section by section basis. Once we feel like something, one section is complete, that's a valid release point. Okay, and at the bottom here is a huge set of tables that list all the Propeller 2 assembly instructions in categorical order. So these are all the math and logic instructions. There's another grouping down further. And if for those of you that are familiar with the documentation that Chip has available, all of these are in spreadsheet form because they just simply don't fit very well on a document like this. So I had to make some compromises to try to squish the information in here and decide what is really important for this particular document. And of course, in the Propeller 2 manual, we'll have more detail than what is described here. And then I'd like to point out at the bottom here is some more stuff that Michael's been working on, which is the electrical ratings. Some of this from the test, some of it from the design specs themselves, and there'll be more to follow than this data that is going to create some nice little graphs that will help us visualize where the boundaries are for how this thing performs in the real world. But all the test data, if you've been following the forums, has been really encouraging, I believe. I don't think there was anything that was surprising in a negative way. It was all really good news. So that's one thing that we've released today. The next is the Propeller 2 questions and answers. So this is a, let's see, do I have this up here? I think I have it in a different view. Whoops. There we go. Okay, so there's one thing that I'm always focused on as I'm looking at a complicated topic like the entire Propeller 2 as a whole, and that is various things that a lot of beginners and even experienced engineers are going to be asking. And I'd like to provide that information in a very topical fashion that is hopefully very, browsable and searchable, and hopefully, raises the general level of knowledge of everybody up quite quickly without pouring through an entire data sheet or manual. So that's what this questions and answers spreadsheet is like. We provided it in spreadsheet form right now so that you can comment on it for one thing, because it's a shared spreadsheet. You can go in here and just right click anything and comment on something that you think might be wrong or may need some more information, or if you have some other ideas to share. You can also do things like click up here on the column and sort by a different sort pattern so that you can kind of get a different view. So there's quite a lot of material here, and there's way more that I have kind of sitting in the wings that I'm going to be putting here probably by the end of this week. So check back, and it's all been written with the Propeller 2 in mind specifically. Some of it applies to both propellers, of course, some of the more general topics. And some of this material actually came from the Propeller 1. I will show you some, like this is how we presented it in the help. Can everybody see the online help screen here? There's this little questions and answers section, and you can kind of step through here and just pick something that's of interest to you. And this is what I mean by the topical nature of all these little knowledge bits to give you a better feel for how the Propeller works and what kinds of things you could do with it. So there are real simple questions and some more advanced things. And even I think I have some little tips interjected in here. So we'd like to provide the same kind of thing for the Propeller 2 going forward, ultimately, and hopefully some kind of form like this that's available on the web that anybody can step through. And for now, what we are hoping is that everybody steps in here and reads through all this stuff, and then suggest things for us that we don't include. So for example, you could go to the bottom, like somebody here already put something. Here's another question: is the P2 RoHS compliant? Right. So you can just go on a blank column or excuse me, a blank cell, and just right click here, enter some comment about a different idea, or maybe even a whole category of questions that you would like to see answered here. Okay, so those two things are available right now, the data sheet and the questions and answers. And then, in addition to the commenting, which by the way, that's preferred that you live comment on the P2 data sheet and the questions and answers document. If there's something that's that's not really conducive to, or you want to provide some extra materials for consideration, you can email editor@parallax.com. But for little stuff, things that are easy to put in those comments, we'd much prefer it there, because then it's right in the right place of the document that you're talking about, and it's easy for us to get notified and go check it out. And then for the future, we have, so the data sheet we expect to be updating quite frequently over the next couple of months, probably sort of winding down around the end of June, early part of July. Stabilizing, I mean. And at the same time, we're building up the P2 manual, which that will be the first release you will see, will hopefully be the first week of June. That's what I'm planning. And I think that's what Ken has planned for me too, so I'm really trying to stick to it. And the P2 questions and answers, I put May through June here. That's probably just kind of a stability period, but it could really go on and on. We could make a whole database of nice little knowledge bits about the P2, which would be really handy for people to jump into early on, or even after they've been using the P2 for a while. And then ultimately, our distribution plans are to make this stuff available in PDF form. I don't know about the Q&A, that really doesn't fit. It's not super conducive in a PDF form, but in either case, these materials will always be browsable and hopefully searchable and very topic based on our web. My dream is that every little bit of information that's in any of these documents is easily findable, through just some Google searches or a targeted search from our website, or a link that you follow from one of the Propeller development systems. Okay, so let's see. That's about it. Does anybody have any questions for me?
For questions, Jeff, can you show us again where to get the documents for those who joined late?
Yes, so let's see, we go to the main Parallax site here. And right up at the top, there's a menu with Propeller on the left side. You go down to Propeller 2. Whoops, hopefully you do it better than I. And then over to documentation. So this page that you see right here is bound to change quite a lot over the next few weeks. Right up at the top are downloads for the data sheet, which you can, if you click on this, it'll give you a description of what it is and then give you download links there, or you can click just download right here at this point. There's also the spec sheet, and then we've moved this Quick Bites up to the top because that's a great resource to look at. In fact, I think that's getting so big that we need to start categorizing some things. So we're going to be working on that. And then what we have under the community documentation is things from us and from, John Titus. These two documents about SmartPin and Send, along with the 3 core documents that Chip provided, are what is being, that's the focus of what's being considered for the data sheet and the Propeller manual content. But I have actually been looking at some other materials that people have discovered themselves, or filled with information that they've discovered themselves and provided on the forums. So again, Propeller 2 documentation is the place you want to go. And again, that live link for the Q&A and the Propeller data sheet are right here at the top of this community documentation section. And I think there's a link to the data sheet in the downloadable form, the PDF form of the data sheet as well. That was something that changed just this morning. That's why it's a little fuzzy in my head about exactly where it is. Any other questions? I don't have the chat.
Yeah, let's get some comments, questions for Jeff of all kinds. Like what people might be expecting that they're not receiving, or sorry about that. Any kinds of questions or comments for Jeff, you can ask them or put them in the chat.
Jeff, once you have the manual going, are you expecting that to be a public thing too as you make progress on it? And then PDF releases? Yes, I do. We will make that a live document as well as a PDF, just like we did with the data sheet, so that people can continue, reviewing it while we're continuing to write it. And we'll have, I don't know, I'm expecting that to continue through July for all the intense work on it. I welcome comments from people, and hopefully we can make something that is just as helpful or better than the P1 manual. This is fun to see, Jeff. You're making progress. It's exciting. Thanks. Yeah, it's funny how
it goes, because I end up learning a lot whenever I do this. I think they say that best way to learn something is to try to teach it, and that's definitely holds true here. There's a lot of material in the P1 documentation that I had no idea would ever be there, but it was some, little caveat or an interesting behavior that I noticed, and then explored it, and then wrote about it.
Yeah, Jeff, I got a question for you.
Yes.
Is tacos going to be mentioned or covered in the documentation?
That's a good point. Yeah, I think we should talk about that. So I think the answer is yes. That's a good, in fact, I'm going to write that down, because that's.
There was, along those same lines, I was starting to think of as you first get your P2 hardware, there's this effort of getting the base hardware. What do you have once you have the base hardware? And you kind of have the fourth built in. All you need is a terminal. Then you start adding things like the Propeller tool. And now you have additional language you can work with. Then you add external compilers, and now you even have further languages. And so maybe there's almost a timeline aspect to the introduction of, as you add these things, these are the capabilities you have, these things being tools.
That's a good idea, and that really goes along with, the start of the data sheet or the manual, where it's kind of introducing things a little bit at a time, including a minimal connection diagram, which most people aren't going to do themselves because the chip itself is hard to manually solder. But at least it gives you a good concept of this is all it takes, and then here's the next step, and then here's an optional step. So that's a good idea. I like that. Talking about here's what you have right out of the box, and then moving forward, stepping into additional software. So I don't expect that we'll ever get to the point where we could cover the plethora of development tools that are out there. We certainly want to point people to it, because we love the Propeller community and how everybody gets together and creates neat things, and we never want to hide that stuff, right? But I think if we focus on what is built into the Propeller and built into the parallax environment for the Propeller, and then also talk about, or at least introducing people to all the other compilers and the other IDEs, the VSC work that you've done, I think that makes for a well-rounded, set of documentation. And there's plenty of other resources out there, to dive deeper into those topics as well.
Yeah, Jeff, there is a comprehensive write-up on tacos with the P2, and it's called the Bit Basher's Guide to Parallax P2, and the author is Bob Edwards. And I got it off of the Google Docs somewhere. I don't have an email or the URL for it, but that's pretty comprehensive.
I'll look for that. I've probably seen that. It sounds familiar, because when we were originally testing the P2 engineering samples, I needed to twiddle some move some pin signals around, and it was nice to be able to just jump into something. I think I just searched for it on the net and found some tacos information, and did it from there.
Yeah, you might just be able to cut and paste this into the manual. I mean, it's that well written.
Oh, good. All right.
After you get authorization from the author.
Ken, are there any comments in the chat window I should address?
some positive feedback for the data sheet.
Good.
And to maybe harvest the tricks and traps thread.
Ah, okay. There's something here I see from John McPhalen about printing it. So yes, we have heard you and others that say that they really want a printed manual, and I completely understand it. I'm in the same camp where it's nice to have a printed manual in front of me. Anymore these days, I tend to do a lot of searching online, find little bits of information, and then I dive into stuff that way. So I don't have manuals very often, but we wanted to be sensitive to that. So I actually did a lot of work trying to make sure that we don't encroach on 3-hole punches that John mentioned here, because people will be likely printing out sections of the manual or maybe the whole thing and binding it themselves in a binder. And so I looked at all the 3-hole punch specs around the world. Believe it or not, there's a lot of them, and kind of came up with a, the extrema to figure out, okay, so how far can we go to the edge? How thin can we make the margins without likely causing text to be cut off when somebody punches it? So we are keeping that in mind and formatted things so that that should work pretty well. Did you say there was another one, Ken?
Not particularly. I think just the tricks and traps. And I think too, from the community, is this what you expect from us? Let us know. And I'd like to point out too, to get updates, subscribe to the newsletter. So if you don't go to the website, we can let you know that way. And the newsletter is a primary tool that I use for communicating, and then the forums, which are also important, I go to second when there's time. But I think the community will see updates and they can share with each other.
Yeah. That'll
help us a lot.
Somebody mentioned because it might be a 600+ page monster of a document, a 3-inch left side margin would be nice. Totally understand that. Needed a big binder. We can't do a 3-inch margin. We'll have very little space in the document to show what we want to show. But because the document will remain live for the foreseeable future, you will be able to, make a copy yourself and then adjust that left margin before you print for whatever size that you need. It might bump things around a little bit, but hopefully things will flow well onto additional pages for you, and then rebuild the TOC. That reminds me that so we do intend to release, do multiple releases, updates for the P2 datasheet in the immediate future, and the P2 manual shortly after that. So how, when you get one of these updates, let's say that you're focused on the PDF, how do you go about figuring out what we've changed? So I did some experiments and found that if you get a good file difference engine like Beyond Compare or Araxis Merge, or the two that that I know about or have used personally, both of them support opening up PDFs, and it will show you the textual differences. It won't show you the graphics, but it will show you the textual changes that have happened between 2 versions of a file, or even 3 versions of a file. You can do a 3-version compare. So if somebody really wants to go that far, it's actually really quite easy to see, oh, they changed this figure here, they changed this sentence there between last week's PDF and this week's PDF. That way you can kind of follow along as we go, because I imagine we'll be making hundreds of changes,
I was
enhancements along the way.
Talking to myself. Have you experimented with change bars in the document along the margin or something? Does Google Docs support that?
I don't know if it supports that. It does certainly show in the live document. You can go back to previous versions, but unless we do a named version, it can get very busy.
Yeah, of course.
You know, daily changes, hourly changes show up in there, even more granular than that.
Right, just the change bar concept, something along the left margin. That
Yeah,
is
you're talking about like a little
don't-
blue or red
Yeah,
line or
exactly.
something that indicates something changed here.
Yeah, if that were feasible, that would be useful. The diffs are going to be, I do diffs routinely for large code bases, and it's a lot less fun than you might think pulling up a diff for doing documents and trying to find out what changed.
Yes, no, I agree with you.
Yeah, so, but you know, if it's the only thing we have, we'll be okay using it.
But it might, I guess my point there is, you know, there might be whole sections that have not been touched between two versions that you're looking at, and then a whole new section or another section that's been heavily revised, and it would at least point you to the right area, and then you can just go read through the actual document in that, you know, those few paragraphs or that section, and hopefully find some rewarding changes there.
With respect to your large sections change, another thing you could do if you were willing or interested would be kind of a change log annex, and then annotate the big changes back there with links back to the pages. And that would be useful as well.
Yes, I believe we are going to do that. Stephanie and I were talking about that this morning before today's release. So right at the end of the document, there'll be, you know, kind of an overview of what seriously changed here. Not hitting every little tiny point, grammatical issues and stuff. That's you know, neither here nor there. But the real point of it, I think we will do it. Stephanie says Google Docs does not support that side margin change notification that she knows of.
Yeah, I was just looking for that too, and it's difficult. Nice. Thank you, Stephanie.
Thanks, Jeff, for taking charge of this and mobilizing and being part of the team, and Stephanie for keeping this going and outputting everything and proofing it and making sense out of it.
Yes, and I'd like to thank Stephanie and Michael for their contributions too, because I really couldn't do it without their support. I don't know if anybody else has written documentation, but going back and forth between trying to write understandable sentences and then build diagrams or focus on grammar is just a little too much for my head. I have to, it's nice to be able to delegate that stuff, and you know, each of them, you know, tend to look at things from different perspectives, and they've definitely pointed out some things to me that this section doesn't seem to belong here. Should we put it somewhere else? And that starts some lively discussions, or maybe just a quick change. Oh yeah, you're right. So it's great to have a good team to do this, and I really see the Propeller community as part of our team too, going forward with this, because we don't always know what you want to know. So we're really looking for those, you know, points that you would like to find out, stuff that you haven't found in the existing documentation, or questions that come up from, you know, the different perspective on the P2 that you read from my writing in the data sheet or the manual. That's bound to happen. Go ahead and share it with us.
And Jeff, we'll do our best to allow you to work in some isolation and freedom without disruption.
Thanks.
We know that's important, so feel free to turn off your email.
That's very difficult to do. I could push it aside for a few hours. Otherwise, it gets out of hand. But yeah, thanks. Okay, so I think that's it for me.
Yeah.
Let me check the last.
Thanks,
few
Jeff.
comments
That's
here.
looking super good. And Stephanie and Michael.
You're welcome. And be prepared for a lot more deep questions from me very soon.
Just send them over.
It's quite a way to learn how to document something, isn't it? One
It
guy
is.
in the team creates something, and then you get to learn about it in pieces.
Yeah, well, it sure would be a different story if Chip hadn't written that core doc, though. I'd be really lost. I wouldn't know what I was looking at. So that's been a tremendous help. And I've pointed out some things to him that I think that he didn't realize wasn't documented. You know, because something he wrote, you know, brought up an idea of mine, and I went looking for it, couldn't find it, and so told him about it, and then he puts that in his core doc.
It would be really neat if we matured the documentation enough so that by March of next year, we can make a printed version to hand out to people that come to Parallax for an unannounced special event.
That would be nice.
We'll have to talk to Stephanie about that at some point. So
Are you talking of the manual itself? That might put people over their baggage limit weight getting home.
oh, you're right. And shipping costs have become very high too.
Yeah.
That's why we offer free delivery for people that walk up to the door.
Of a memory stick.
Memory stick.
Okay, so as we move into...
Thank you, everybody.
Thanks, Jeff and Stephanie and Michael. So now we can go wherever we want to with our P2 Live forum. Before we do that, though, I thought I'd just take an inventory to see if there are any topics of importance to people to be discussed today. And if any, you know, support issues, I think Chip was going to talk about how we finalize the P2 Edge revisions.
Michael is here, I think. I don't know if his eyes are still open. It's like midnight for him.
We shouldn't expect anything of him. He's in Eastern European time zone, so he's probably horizontal by now.
But he's logged on to the meeting though.
I'm floating around.
There he is.
shoving some traces left and right.
They'll need reshoving in the morning.
Oh, well, maybe not if we don't talk later.
You know, you guys are being cut off from communicating because the bomb is entered and parts are ordered.
Yeah. Oh, that's true. Yeah.
Well, do you want to talk about P2 Edge then, Chip and Michael, generally, or in any detail? Or
Yeah, Michael's got all the latest stuff.
Yeah, I could show you the. I could do a screen share real quick if there's any interest in that. All right, let me just. Yep. Ken, if you could talk for a minute, and I'll just render this.
Sure. While Michael gets set up, I just want to thank an anonymous donor out there who sponsored a Skyfly transmitter to be sent to Kevin. So I've arranged that with Amazon here in the background. Thanks, and I'll let you know how I could take your money.
May I ask a simple question? What do you mean by P2 Edge? I've always been confused by what people mean. And I read a lot of technical documentation. What exactly is meant by Edge?
We're referring to the P2 Edge as our module.
Yeah,
this
thing.
Oh,
here.
it's a printed circuit board.
Yeah.
Okay.
And it could be called a card.
Got it.
But it's used, maybe the Edge connector is where it got the Edge name.
Okay. Good. I like Edge connectors. Yes.
So, and since you asked, we have several types of connectors with the hope that people design this into their products. We have a connector that's vertical and one that's horizontal. I think that's it. Yeah, we have two different types of connectors. So most common use would be on the Johnny Mac board, this board, which we call, it's part number 64020. And there's also a mini breakout board that can hold it. And then a prototype board.
Thank you.
Yeah, you're welcome.
And the P2 Arcade.
And the P2 arcade, yeah. So we're seeing it being used in several form factors. And what Chip and Michael are talking about are some revisions that we're making to it. So we're making a revision C of the P2 Edge. And then following that, we're making a version with RAM.
Yeah,
Nice.
we run it through a couple different iterations because we find things that could use improvement. In this next one, it's going to be like a 5 to 16 volt input range for the power. And it will also have a 1/2 part per million accurate clock.
Oh,
Chip, you'd mentioned that really precise clock last week. Will you actually get that 1/2 part per million at the actual CPU clock speed, or is that just at the low frequency that it's going in at?
Well, at the 20 megahertz output, it's that accurate, but because the phase lock loop is phase locked, it doesn't like go, it's going to run at some multiple, how would you say, like a multiple and a division of the speed. So of the 20 megahertz. So you're not going to like, it's not going to like add clocks ever. It's going to be phase locked to what the 20 meg super accurate time base outputs.
What I was thinking though is if the 20 megahertz is plus or minus 500 parts per billion, 300 megahertz would be, say, 15 times worse, wouldn't it?
No, because it's still a ratio.
Okay.
Yeah, it's a kind of like a percentage. It just stays the same no matter what the number is.
The other question I was wondering is, you mentioned it was expensive to get that crystal. Would you be thinking about using a standard crystal on the generic board and a special build for, say, the high-end one with a high accuracy clock?
Well, the reason we went to this thing, and it's instead of 20 cents for a crystal, I think this part's about $1.40 or so, $1.46. But we had this problem that we realized that because the XI and XO, those are the crystal oscillator pins, because they share the same V in supply as P28 to P31, if there is some like real high speed switching, like multiple, like say all 3 or 4 pins switching at once in the same direction on those last 4 pins, it can create kind of like such a voltage spike on the internal power supplies of the chip because there's such an instantaneous current draw that if the crystal, remember that 20 megahertz crystal oscillator, I mean, when we hook a crystal up to the pins, it's creating a sine wave, right? And it's slewing very slowly. It's like 10 nanoseconds per volt. It's very slow. So what happens is if that thing is crossing the logic threshold slowly and you get one of these spikes in, the perception inside the chip is that it goes like this, boom, boom, and you get an extra clock. And that causes the PLL to go nuts and try to lock to a higher frequency, which is inconsistent. So it creates a lot of PLL noise. So the way around that is to use a very fast edge going into the XI pin. So rather than a crystal, we use an oscillator, right? Because it's going to transition in like, fully transition in like a nanosecond or 2. And that way we cross that threshold very abruptly and we can't, it's not going to perceive 2 clocks on the inside, even if it's commensurate with 4 digital IOs toggling in the same direction at the same time on P28 to P31. So I should have put in to the chip a little Schmidt trigger to input the clock. Instead, I have like some series inverters. And the problem is there that we have a very fine logic threshold. And if we're slewing past it when we go from 0 to 1, and we get a big bump on the power supply, it goes like 0, 1, 0, 1, right? And that extra clock gets registered by the PLL and messes everything up.
Oh, got it.
So as long as, and then there were 2 other things. So as long as we have to go to a crystal oscillator in order to get that slew rate that we need, then we want to have something kind of low current because a 3.3 volt oscillator takes a lot of juice, like 7 milliamps, whereas a 1.8 volt takes only like 1.3 milliamps. So it's a lot less power, you know, because you got to multiply that by the voltage too. So it was a lot, you know, we could add a 1.8 volt oscillator for very low power cost, and for a couple dimes more, we can get a real accurate one too. So that's why we went this way. Low quiescent current, high accuracy, and high slew rate into Xi. I'll say, okay, let's say Jim, who warned me we needed a Schmidt trigger on the inside of the chip. He just posted, he said the 0.5 ppm is over temperature and is true for any megahertz. There is also an absolute reflow error in the spec sheet. So after reflow, the tolerance goes to plus minus 1.5 ppm. Well, Jim, how can they advertise then 500 parts or 500 parts per billion? Everybody's going to have to reflow that thing, right? So no one's ever going to see this 0.5 ppm. Maybe Jim will speak up and say something about this.
So we have Michael back, Chip, and maybe we can get him to do some screen sharing.
Yep.
Okay. And Jim Granville, if you want to say anything about this, speak up. I think we've never heard Jim's voice. He's a typer.
But he's made 1 million pages of contributions on the forums. He knows the DigiKey catalog.
I think he knows every catalog.
Did you get this part out of DigiKey?
Yes.
Could you, in the forum chat there, could you type in the either the description or the part number?
Yeah, let me find it.
I mean, a Chip, because I can go round it up while Michael's talking. In fact, we will share the whole layout, the bombs, all of these pieces with you in case you wanted to use them.
And Chip, there's another answer in chat for you from Jim.
Ah, Jim. No mic here. Okay. Yes, you need to calibrate TI. What is TI? But after that, you are 500 ppm. Then there is thermal aging of half a part per million per year. Oh, okay. And Jim just put the, thanks, Jim. So he just put the link to DigiKey also up. So how do we calibrate it? Because there's no voltage input for it, right? Maybe Jim will say something about that too.
All right, Michael, what is this beauty?
I can't see what you're seeing, so let me know if it's.
Yeah, looks
let
like
me know
your
if
desktop.
yeah, as long as the scale is good enough to see what's going on, that's all I'm worried about. Okay, so this is the this is what the upcoming Rev is going to look like, the Rev C. And I think this is the image Chip showed last week. So what we've added, the dip switches over on the left-hand side are missing from this 3D model, but they're the same as the existing Edge model. But we've got new power supplies here that accept a wider voltage range, something like 5 to 15 volts. The SD card at the top here is new, so there's an SD card socket there. And the new crystal that Chip's talking about is down here on the bottom right.
Yeah, the oscillator. And see, we also, we're getting away from these, this won't focus, but these little ceramic inductors break easily. Like I just dropped this on my table when I was talking to Michael the other day, and it shipped off, probably changing its inductance. So these new inductors are molded, so they can't suffer these problems.
Yeah. So on the image I've got underneath, this is the last change that we made, which triggered me going back to my prior version, which has the RAM chips on. So this will be the version with the RAM chips on that will come a little bit later. But I can actually rotate this so you can see, these molded inductors are super low profile here. So yeah, the risk of damage now is kind of zero, one would hope. But yeah, so the last thing that we are just changing is that there's two resistors over on the left-hand side here. I need to find a space for. They're going to be pull-ups on the TXRX lines. The existing edge didn't have pull-ups, but we thought it's a good opportunity to include them. And on the back of the board, there is one change that may or may not suit everyone. You may recall we originally had some pads down on the bottom right-hand side for voltage in, ground, and the prop plug. But all things considered, it became quite awkward having them there. So we've dropped the separate 5-volt and ground inputs on the basis that if someone really wants to solder a right angle connector onto supply power there, they could just drop one over these edge connectors anyway, because the pitch happens to be right for that. And we've moved the prop plug headers up to the top edge here. So the idea is that if somebody is in the field, let's say there's an edge module plugged into a device and an engineer wants to go out and hook on a prop plug or just touch on a prop plug whilst the edge is still running in its environment, then they could, an engineer could potentially have a prop plug with pogo pins on the end and just press it against there and instantly have debug output or be able to reprogram flash.
Yeah, and you can use those big tool pins as guides down to the pogo pins.
Yeah, absolutely.
Or you could put vias in those pads. If you put vias in those prop plug pads, then you'd be able to you'd have something to bite into. I do that a lot.
Yeah, that's a possibility as well. Yeah, we might be able to do that.
It would be good also if those pads, if you made a line right through the tool pads, that there was a full radius on the pad for the pogo pin, so it could be in line with the outer tool pins. Yeah. I'll drop it down so it's. It might already be there. It just so the radius is fully there.
Yeah, I'm sure it's not there because I literally just dumped it there to show it now. I haven't aligned it at all, so it's just roughly in position. Yeah, I think it will be aligned horizontally with the mounting holes, and then I suspect the silking will probably go on the board edge, not on that edge. And I've set the pins this way so that you could solder a right angle header downwards, so that if somebody wanted to, maybe a road warrior wants to just have a P2 edge to program on the road, or I don't know, that's a bit extreme perhaps, but they could solder a right angle header pointing downwards towards the edge connector, and then the prop plug would slide in that way, and you can program it that way. But the order is important for that because the prop plug will only fit one way round with the PC, coming in from that angle. And then of course from the top you can plug it in either way around because of the it's air there. So so that was the change. I don't believe we've changed anything else.
Well, you've changed the cost of building it.
Well, there is that. Yeah. We've
just having fun with you guys.
Added a few dollars to the BOM. Yeah. You'll have to consider the unit price once these come off the line.
So that SD card socket, that launches a new necessity for a driver.
Yep.
Yeah. And I know a few people have their hopes on chip writing one. And I think the most advanced one that I'm aware of is the one from Ray.
Yeah.
You're talking about SD driver, Ken?
Yes.
Ale, the SIDCOG guy, has been interested in doing a file system for the SD card.
That's right. In fact, you put me with him at one point. I need to follow up on that.
Anyway, so here's the just before I go, here's the dip trace view, which is always interesting. So we've got this down to 4 layers now. I think that's been mentioned. So we've got the important thing is that we've got all the power, all the high current power at least, all on the top layer. So it's not having to go down through vias and back up again anymore. So we've got rid of all that impedance and inductance. So here's the VDD, so the 1.8 volt bus. Oof, there you go. So that's all solid straight through. And then we have the other power plane there, which is the inputs to the LDOs. Don't worry about some of these gnarly looking traces, by the way. They've just not been made nice yet. So that's the other power plane there, and then some other signals on top as well. And then layer 2 is just ground, apart from the straps across for the 3.3 volts coming out of the LDOs into the P2. I need to look at those at the end of the process to make sure we're not crossing any planes in a nasty way, but otherwise that's all solid plane. And there's a little 1.8 volt trace there feeding into the crystal circuit. And then we'll have the core, and then layers 3 and 4. 3 being the signals. All the signals are on here. Again, don't worry about funny looking right angle traces. They're just not been routed in yet. But all the signals are all down on there. And then that'll be tightly coupled to the ground plane on the back. And of course, actually, I haven't looked, having added that pad there, if that's going to sit across traces, but I need to make sure it's not, but we'll get to that. But yeah, so that's the stack up now.
Michael and Chip, is there any indication or thoughts on whether this new P2 Edge design will have a positive effect on that one port that we found has issues with high-speed signals?
Oh, well, yeah, because it has, you mean that caused the VCO or the PLL to go mad?
I don't know all the details about it. I think that there was video being run.
Yeah. And they would become jittery.
Yes.
Yeah, that was because of high-speed switching on P28 to P31. So by getting rid of the crystal, which slowed very slowly, and putting in a nice sharp, crystal oscillator with a 3.3 volt inverter, it's going to deliver nice sharp edges into XI. And so there's not going to be opportunity for these upsets anymore.
Great, thanks.
I wish I just would have put that Schmidt in there. I wonder if, Ken, at some point we could talk to onsemi about doing a rev that wouldn't involve any more synthesis, but just cleaning up some stuff in the pad frame. There are some little improvements we could make to the ADCs, like the calibration resistors. And then there is this clock issue. And then there is also the latch up problem. Remember that?
Yep.
So anyway, I don't know if they'd be game. They probably want to see us sell a couple 100,000 more of these chips before they entertain that.
Chip.
Yes.
A question to you, or perhaps to Michael Mulholland. And excuse me if I spell his name awkward because my speech is terrible. About the P2 Edge adapter, that small PCB that has only the Edge connector and some other connectors around, not the Johnny Max one. I did raise it. Yes, yes, I did raise it the question. What will happen with that board if we use other than 5 volts input into the edge? Because that board relies on 5 volts coming from the edge, perhaps, or something, to feed the connectors around, the pin connectors around. So if we don't have
Right.
5 volts, where should it come from?
Well, we don't have a regulator on here.
Yes. And
and
also,
so-
I believe in Johnny Max, we don't have a regulator in Johnny Max board, or we have a regulator in Johnny Max breadboard setup.
Oh, we're going to add that. Are you still there, Michael? We're going to add, in fact, to the latest one, didn't you put a 5-volt switcher on that board?
So the plan is for the Johnny Mac board, the plan will be to add a 5-volt regulator of some sort, so that if somebody does connect high voltage input, then you'll still have 5 volts available. For the mini board, we have thought about it. The problem with the mini board, or the issue, is that that's the one that really wants to be as low cost as possible. And if we start adding regulators, we're just going to, that's not going to work. So the current thinking is to change the silkscreen labeling of the headers where it says 5 volts. We'll probably change that to something like V in.
All right, so if they want to use a 5-volt module, they're going to have to plug 5 volts into this thing.
Yeah. And what we might do is add a 2-pin header, or possibly a 3-pin header, possibly behind the barrel jack, which will enable people to enable and disable the power connection to those, so that if someone is using a 17-volt input or whatever. We haven't actually ran the final test to set the upper limit yet, but it'll be 15, 16, 17 volts, something like that. Possibly 15 volts, just to derate it a little bit. The main thing on that, just to digress on that V in range, is to get something that's over 12 volts and over the sort of typical charging voltage for 12 volts. So 15 volts might sit quite nicely, or 16. So anyway, if we put a 2-pin shunt jumper there, then people could disconnect it if they're using a high voltage in. And if they're running 5 volts, then they can just connect the jumper. So that's one way of doing it. Another possibility with that same jumper arrangement is people could take the shunt jumper off and inject 5 volts there. If they've got a header pin available, that could be a source, and then they could still use a different voltage at the barrel jack. So there's a few options there. And we hadn't actually finalized the decision on the Johnny Mac either, because that's also another possibility, is to provide, whether we go for 2 voltage inputs or stick to 1 and have a voltage regulator. So there's some things to figure out there.
For 2 capacitors and a small, like, through-hole part, we could put a 5-volt LDO on there.
On where?
On this thing.
Oh no, you'll double the cost.
Yeah.
So I mean that has to be the low cost entry thing.
Right.
People, there might be 10% of the people that want that, but most people don't want to pay an extra $10. They want to get it as cheap as possible for a basic breakout. And that was the principle of the original design, was keep everything 5 volts, so it keeps the cost down for everyone. Yeah, and the same is going to be true of the Johnny Mac. Adding more regulation is just going to push the price up for everyone. But
we have to do it on that one because they're going to plug in all kinds of things. Yeah, this has no components on it that are like active or passive. It only has, headers, push buttons, and connectors. That's all it's got.
Yeah. So adding regulation there just makes the thing bigger, doubles the cost.
And Michael, just another thing. I believe you did posted a mock-up for that board into the threads, and I saw in the mock-up the power connector is set up in line with the edge connector, very near to the side of the connector. In the last forum meeting, I raised the question if people making plastic shields, not plastic shields, but plastic. Oh, I don't remember the name, to put around the P2 edges. Does will not interfere with the positioning of that plug, with that power plug by the side of the edge connector? Is there any space between the power plug you did show in your mock-up and the edge connector, or they are close together?
I suspect there's space, but I'm not clear on which board. Which board are you talking about? The breakout board.
You did post, yes, the mini breakout board. You did posted a new mock-up, I believe a week ago or so, into the forums to show what.
Let me check. I actually don't remember, so I'm glad you. Let me see if I can find. Well, anyway, I can answer the question. We're certainly not going to put anything so close to the connector that you won't be able to use the plastic housing that that was posted on the forum.
Okay, because I saw some plastic housings to the edge that has a protrusion of plastic involving the edge connector. So I was concerned about those plastic shields interfering with the connection, because the power connector is very close, seems to be, at least in the mock-up, seems to be very close to the edge side.
I think we would certainly have something like a 5mm gap at the two.
5 millimeter? 5 millimeter? Oh, no. It's good, because I believe the shields are about 1 millimeter of plastic or so. Okay, thank you. The mock-up didn't show it clearly, so that's the reason I raised that question.
Yep, no, good point. Good point.
Hey, Michael, Jim posted a link, the LCSC link. We could buy all those things for 57 cents each. And they're the package is $32.25. Is that what we're using?
I don't believe so.
3.2 by 2.5 millimeter. Or were we using a 2016 or something?
Pretty sure we're using 2520, 2.5 by 2 millimeters.
Okay. These we could buy for 57 cents each. And the ones that we're looking at are $1 more, right?
Yeah.
What's the part description for this one, Michael?
Well, it's the oscillator. Do you want me to give you the, I'll text you the part number in a minute.
I think I found it.
It's the Epson part, but this one would save us almost $1 per unit on the first, well, probably going forward forever. But they have 1,400 in stock.
Yeah, their reel is 2,000, so that's going to be a split reel, which is annoying.
I have a question of a different nature. Will the new, or are we looking towards the new layout for the P2 Edge? Will it afford us any better environmental test, stress test on the P2. I know that it's 4 layers instead of, what was the previous one, 6, I think. So there'll be some thermal differences that might be helpful for our heat tests, but didn't know if you had considered anything about that.
Yeah, we went over this, Michael. We were going to rate this thing for, was it 85C?
The edge module, yeah.
Minus
Yeah.
40 to 85C.
Yeah, because the pricing of the clock crystals and the caps just goes silly once we start pushing to 105 even. So yeah, the edge module is definitely going to be 85 rating, and but the P2 chip itself is rated at 105 at the moment. It's just a question of cost. If you want to have, you could build the edge module with higher temperature rated components. It just adds, again, it's sort of adding a fair few dollars to the cost for everyone. So a customer that needed that could certainly build an edge module version that runs at high temperatures.
Thanks.
Michael, you think it'd be good to switch to this part? It's 3.2 by 2.5. I think it's the same footprint otherwise. I mean, the pinout's the same, just bigger. But
yeah,
we'll cut a whole block off the BOM.
Yeah, I'll go through all the details and check it. I'm just actually having a quick look to see how it fits in terms of footprint.
One thing we can never tell is the actual importing cost of these.
Oh yeah, that can blow things up.
Well, it's variable lately.
It's China as well, isn't it? So you've got the tariff.
Yeah, the reverse tariffs. I just imported 150 kilograms of servos from Taiwan, where they're made in Futaba. So 150 kg of, a fairly large person. Total cost, $1,800 of freight alone. But anyway, these are little popcorn parts. So
like a plane ticket for
it's
a person.
A plane ticket, yeah, and that's not even counting the tariffs. But from China, we can count on doubling the unit cost.
Yeah, so.
And I don't know where Jim is. Maybe it's easier in New Zealand to buy there.
Yeah, well, we can buy from Taiwan pretty easily. We just have high shipping costs, right?
Yep.
But no tariff.
Right. But they will have, I don't know. I shouldn't say what the situation is.
You mean you don't know?
Well, sometimes Taiwanese have to pay, I don't think they have to pay tariffs, but we have tariffs with Taiwan too. They're just not as big.
I see.
But we'll go wherever you guys want to go here.
This is the way everything works. The price is not really the price.
Yeah, the spec is not really the spec. Nothing is what it seems.
Yeah. So availability of this, it looks like, I think a month out. That's the way it looks to me. And then,
yeah.
Okay, because PCBs are not ordered and parts are getting ready to be ordered.
Yeah, the board build time, I think, will be that'll be the slow thing.
3 weeks, Yeah. Yeah, even Jim pointed out on his last shipment for 4 kilograms was $90. And I assume that's to New Zealand.
No, he says US dollars 87.94.
What's the cost going to be on the new one?
Same.
Still going to be the same price?
Same price, yeah, same retail price, but our net cost goes up like $1.50, Ken. What is it?
It goes up easily by $2, but if we really factor in our NRE and then pick and place and parts we're throwing away that we're not using anymore, it really goes up by like $7.
Yeah.
So just want to be totally open. The economics of the P2 Edge are very interesting. And we all want it to be $49 for sure, but it's under threat for sure. Because just to be totally transparent, our average gross profit on is $10 per unit. It's really not a very highly sustainable effort at the moment. So maybe you can buy a lot of them, Greg. I know you already are. Thanks. And then we have the RAM version coming. We didn't discuss that yet, and that'll be next up, right?
Yeah. Yeah. And we need to figure out pricing on that as well. So.
Yeah, I'd love a little more community feedback on P2 Edge pricing too. Just what people expect and what they would hope for. It'd be really nice if they gave us some guidance.
Well, we know what the answer is. It should
Free.
be like
free.
Free or $9.
Yeah.
$4.
$4. It has
That's
to be
it.
$4 now.
Yeah.
But provided Enrique's project and Francesco's project and everything starts taking off, we can support that. We have the volume.
Yeah, well, there's the thing is leveling out now design wise. So this is where we incur like lost costs, like parts that we used on the first rev that we bought lots of that we won't use on the future rev. That fades over time.
So when you go to your next rev, you're not going to be producing any more of your original rev?
No, this is a Rev C, so it's considered a replacement.
Did you make a comment last time that you had a lot of unpopulated Rev 1 boards?
I'm sure we do.
How many do you think we ordered? Didn't we build like 500 or?
Yeah, but usually that's a pretty minor expense because we plan that, we run that pretty tightly. It's the components that we have to buy in larger quantity because the price drops significantly. Like it goes down to a half or a third, as you can see.
You ever consider selling just the blanks?
The PCBs alone?
Yeah. They might make good collector items.
Oh, yeah. Not so you could populate them, but just so you had one, right?
Right.
Come see us in March.
That sounds like something we could just drop in boxes.
Yeah, it is.
Like a mystery box thing. Just throw a bunch of blanks in there.
Well, you know how mystery boxes get created, right?
Yeah. Big jumbo size key fob.
Yeah.
That could be a good key fob to have the USB stick with the P2 manual on attached.
Yeah,
Well, couldn't somebody take a blank and populate it themselves?
I don't know.
I
Why
have.
not? Yeah.
I've hand soldered one of them. So, yeah, no reason why not.
You know, Jim Granville's cost it comes out to just about $10 per pound to receive from LCSC. But then he has no tariffs. So I think a reel of those oscillators would weigh only like probably less than half a pound, right? but there's going to be a minimum, like probably $20 or so.
Well, when you guys make the decision, we'll order and find out if you want to do that.
All right. Hey, Ken, do we have the ability to cut those arcade cabinets with our laser?
I was just thinking about that. We have a 75-watt Epilogue. We don't do well with wood, and there are a million shops that do wood very well, as I found out from working with another customer, and one shop in particular in Santa Clara that I would just send them out to have them cut up, is the answer. Wood is a little bit scary for us.
Can they do anything to control the sintering, like blow lots of air as they cut so they don't get a lot of black around the cut, or blow nitrogen or something?
I'm not sure, Chip, but we have found a shop with this other customer I'm mentioning that has come close to producing the very best quality we've seen. They're in San Jose, and they do a lot of like art, steampunk type stuff.
Oh,
so they have gears, and they're cutting with wood. And wood, this Baltic birch is difficult because it burns and it catches on fire. But to be totally honest, none of these shops that I have seen in the USA have come close to the shops in China that are using the pre-finished lacquered material in terms of quality. I could show you an example. Hang on.
I think, nitrogen can be made on site. And it seems to me if there's like a nitrogen flood around the cutting laser, that you could get around this burning problem.
Yeah, this is what you can get from Asia. I don't know if you can see that or not.
Piper, yeah.
Yeah, from shop in China. Just absolutely perfect. Perfectly cut parts, no burn marks. And this has been difficult to duplicate. But I think we just about
that
got
thing,
it.
Those parts don't, like, ash doesn't rub off on your fingers from the edges? Is that because it's lacquered?
I think these parts have been cleaned.
Yeah.
Someone playing Minecraft, Ken?
I have been.
I have one of those too.
You do?
Yeah. Yeah.
One of my clients down here in Southern California, they build all the cabinets for Starbucks. They have 3 CNC machines, and that's all they do all day long.
So they're sheet routing plywood.
Exactly. Doing the same thing you're doing there. They'll put a sheet of plywood in there, and this thing works on it for about 10 minutes. Then they pick the sheet up, it goes over to the next one, and it gets laminated, and then it goes into the next one and it gets sanded. It's all a complete assembly line, and it's fully automated.
Wow.
But probably for what you're doing, the cost would be cost prohibitive for what you're doing there. It would be too expensive.
Hey, I got the Hall effect sensor working on this motor here yesterday, and it takes amazingly low power now. Let me see if I can turn this thing on. Okay. Let's see here. You can see this thing going. It's spinning at like, I don't know, maybe like 150 RPM or so.
Wow,
And
so quiet.
Oh yeah, it's amazing.
What's the voltage and current, Chip?
This is the really cool part. This poor old, look, we got this from Dad. He had this thing, the meters fell into the box. But anyway, they still work. So if you can read that, I don't know, can you see that?
No, can't. There you go.
16 volts, right? But check this out. Look at the amps. Hold on.
Hardly measures.
Yeah.
What? Why don't you grab that motor and
Yeah, that's what I was going to say. How does it do when you
Yeah.
start?
Okay. Here we
Try
go.
to
Let me
lock
grab
it.
the motor. Let me make sure I can.
Okay, wait a minute. We don't want you to mess up your hands.
Not
No,
enough
I'm not
hands
going
here.
to. Let me drag the supply closer. Hold on. Okay, now.
Wow.
Do you have like
here. Now I'm going to put
maybe
my
a
hand
towel?
on the motor.
Is that first notch 1 amp or
2
5?
amps.
2.
Wow.
So now this control program I have is really simplistic. It's not keeping absolute track of position. So if I start to get like a whole phase off, then I have to like restart the program. But see, when I start the program, watch. And here's the funny thing about this. I can I can turn the voltage down. Oh, I turned it down too quickly. Okay, so now we're at 8 volts. See it slowing way down? I'll even go lower. I don't want to go so fast that my thing doesn't keep up and then it seizes, but. So now we're at 4 volts. And so it's kind of voltage controlled because the Hall sensor tells us like, you know, where we need to go next. And I have like a kind of like a phase lock loop in software that just tracks it. So the program just the code that actually does the feedback is like 2 or 3 lines of code. It's real simple.
Nice.
So I can make this thing, let me accelerate it.
So could you set it to spin at a certain RPM, and as it gets loaded up, it will continue to spin at that RPM?
Yeah, what I would do is I would have to add some more dimension to my control program where I control power. Here's the funny thing. It's using like full power PWM to drive, but because it's hitting, I think at like the proper 90 degrees offset, it just doesn't take much juice because it's not like rigidly holding the motor as it turns it. It's just moving it to where it needs to go next. So now I'm at 20 volts and we're only like half of an amp, but it's really cruising now. Can't really, I'm sure you can't tell in the video, but anyway.
Yeah, another thing those are good for besides driving robots is pitching tennis ball.
Yep. Although this motor, you know, it has those electromagnets out at the circumference, and I don't think it's really designed to turn that fast. It's torquey, but it's not really fast. I think it almost has to do with like the reluctance in the windings or something.
Or the fact it carries your children around.
Yeah. Yep. How do I shut this thing off? I'll just turn the power off. There we go. Anyway, using the Hall effect sensor really improved things quite a bit. In fact, here, I'll show you the code. Let me do a quick share.
So Chip, do you have enough experience now with Doug to finalize the PCB hardware and connections?
Yeah, in fact, he was working on that. Yeah, he said he was working on it last night even. Okay, so here, see, the 3500 is like the max power we could have. And up here, I make the pins. These are the pins that read the Hall effect sensor. It's on 32, 33, and 34, right? And so here I program the pull-up resistors, make them high outputs, so they're also inputs. And then I reset the state variable for the Hall effect state. And then let's see, right here, I read the Hall effect sensor. Oh, this could be totally simplified now. I had like randomly numbered pins before, so I don't need this much code. I just need to look at in B and it was 7, and I'd have what I need. But then I say, if it's changed, you know, if the Hall effect reading is changed, then output the new value to a little debug display and then update the state variable. But here's the business right here. It takes the Hall effect reading, which is one of 6 possibilities, and then it converts it to 0 through 5. Then it multiplies it by a full, you know, 1/6 of 32 bits. And then if I put, you know, -8, that could be a +2. But I was just looking around, feeling the edge, like, where is it a little bit more efficient? And as the motor turns, you can hear it a little bit. There would be actually, you know, things down like in this region, maybe this bit right here, this 8, where it kind of like makes minor improvements. But really this thing, if it's 0, it goes one way. If I make this a huge number, it goes the other way. But you can tweak that a little bit to optimize it slightly, but basically you want to add 0 or 8,000 to it. And this could be a plus. But anyway, that gets our angle of where the Hall effect sensor says we're at, right? It takes this one of 6 combinations and then turns it to a 32-bit number. And then that will make it turn one way. This will make it turn the other. And then it determines the error against our accumulating angle. So we want to have, you could just take that straight angle that you're seeing and use it to output back to the motor, but it kind of has this aggressive high current response that's kind of grindy sounding. So what this does though, is this is like a phase lock loop. You know, this says, what's the error? The difference here, and that's going to be -1, 0, or +1. And then it basically adds that, it adds the acceleration or the speed. That's really speed, I guess. And then it adds that to the angle. And that's all it does in this loop. You could get rid of a lot of the stuff, but these 3 lines here are what do the job. But so this gives us nice looking, let me see, I'll run this thing again. Let me turn this back on. All right, here is our, and if I turn the voltage, I'll run the voltage down. So you can see our 3 phases there. And then you can see current on the bottom 3. You guys still hear me?
Mm-hmm.
Okay. Anyway, very low current now. Oh, but you know, I could boost up that current a little bit. Let's see here. I amplified it by 6. So what you have here in the green, the logic one here, that's the reading from the Hall effect sensor. And then this is, these 3 phases are our PLL that are trying to keep up, that are keeping up with the Hall effect sensor. So by varying the voltage, I can actually change the speed, and I've set the power to a pretty high value. But it works, the dynamic with the Hall effect is much better than trying to just run it open loop, because if you're open loop, it'll hold the phase you want, but it's taking lots of power all the time. This way it's like just super low power, because you're only giving it what it needs to move, not to also hold it in position.
Wish I'd had
And then
something
see here-
like this in my power courses in college.
Yeah, I see it turning pretty slowly. It's running at 4 volts now. Let me even turn it down lower. 2 volts and maybe a very small amount of current. Whoops. Let me see if I can go down to 1 volt. Yeah, there's now that's just enough juice to make it go. Well, we need a little bit more. It needs like 1.5 volts. But look at that. And it's, if I try to hold on to it, yeah, the current goes up. Anyway.
That's amazing.
Yeah, there's a reason why they put that Hall effect sensor on there. It makes it work a lot better.
So Chip, is this the same motor from last meeting and you added 3 Hall effects?
Yeah, yeah. See, Doug had designed this board so they can plug in right down here.
Yeah, you're not, your graphic is still up.
Oh yeah. Okay, let me stop this. So see down here?
Yep.
I can't see. Wait, there. Yeah, there's a little Hall effect connector right here. So that comes from the motor. And
So
so
you got three Hall effects. And how did you position those Hall effect sensors on the, in relationship to the coils?
well, see, they just came completely fixed. It's all part of the motor.
Oh, it's already included in the motor. Okay.
It's like one monolithic chunk. And what they did is they put them at very strategic points so that each resolves like 120 degrees of phase in the 360 loop. And so what happens is they space them apart, kind of, there are 3 of them like this.
Mm-hmm. Yep. And
they fire in a pattern like you saw on that green logic display. And they don't really need, I mean, I was thinking, okay, what I can do is I can add any arbitrary phase to that, but really just add 0. You add 0 or flip the MSB, or do nothing or flip the MSB, and you can control the motor. Because I was thinking, well, now I can add 90 degrees by adding like 4,000 hex, but they already positioned the Hall effect sensor, so you don't need to do that.
Right.
And they made it really simple.
Yeah, so I believe last time you mentioned you were getting some weird waveforms out of these sensors, recall? Or was that on the posting in the forum?
I don't remember, but at one point I had I didn't realize how Doug made this board, and I was wiring the motor into what were also along that strip of screw terminals, but it was the actual Hall effect sensors. So I was like shorting the motor windings to the Hall effect sensors, and I couldn't figure it out. And Doug came and looked at it and goes, "Oh no, the motor connects to these over here."
Hey, I'm going to put a link in the forum. I think I put it. Hold on, over here. About a guy that's has a YouTube. His name's Great Scott, and he does the motor without the Hall effect, basically sensorless. And what we were talking about before, he accomplished that with the zero crossing, but it also, he pulses, he uses the current sensor of the 3 returns, the resistor sensor that you had. That's the current flow, and there's a threshold, and when the current hits the threshold, he basically opens the high side FET. It shorts the low side FET on that coil, that one specific coil, and then fires it again like 40 microseconds later. Watch the video. He's basically at the threshold from the current sensor, and he's he's on and off at that threshold before that winding is de-energized. You know what I'm saying? So he's at the threshold. He's probably at the max capacity for torque on this motor.
Okay.
That's a feature that we didn't mention before. And he's doing it sensorlessly, with
Yeah, that's what we want to figure out, because that's ideal. Then you can run any motor without any specific. If you have a Hall effect, that's great.
Right.
But it would be good to be able to run any motor as well.
Well, now if you have a circuit working with the Hall effects, if you adopt this scheme and compare with the waveform and the efficiency current, all that between both modes, you could say, without a doubt, that sensorless is doable and is comparable to a, Hall effects.
Right.
Yeah. So look at that video. It's a pretty good part two.
Yeah, I think also, sensorless would adapt. It would home in on the ideal, because even the Hall effect isn't ideal. They manufacture it to be right, but there are still little tweaks you can make to improve it that probably vary from motor to motor. But sensorless would actually figure all that out just in process of running.
Right. Yeah. Well, sensorless, you got all the information that basically a Hall effect tells you from the coil that's not energized, it's floating, and using that as a sensor, you could dial in, and either you could lag and lead that 0 point for max efficiency, when you do it in the lab.
Yeah.
So in the field, you got, the most efficient component there.
Yes.
So yeah, look at that video. It's quite interesting.
Yeah, thanks, Kevin. It's running on my screen now, but I'm going to watch it really carefully. And
when are these motors going to be available? The ones that Ken mentioned earlier.
Yeah, I'm just looking that up right now. So it says waiting for supplier to ship. We've paid, and they're coming air. And other than that, I don't have any other details, but I'm going to ask them now.
And your product line on your shop, there are no drivers, hardware to drive this size BLDC.
No. We had a motor controller, the DHP10, based on the Prop 1, but it was recently discontinued. So we have at the moment, the only product we're bringing back is the motor mount wheel kit, which are the 12-volt motors, but we're not providing a motor controller for it. Okay. So we're looking forward to this solution.
Yep.
And really trying to move towards these motors, move our customers this direction.
Right. Good.
These are also easier to interface in terms of a bearing block. It's just one piece. So it's like a 2-inch square by 3-inch high chunk of aluminum with 2 set screws in it on both sides. And the motor, what looks like the motor shaft, I guess if you invert the whole thinking of the way a motor works, is really where you secure the motor. So they're easy to mount.
And you'll have engineering drawings, CAD or from the manufacturer.
I need to start asking for that. So I'll take this opportunity now and ask them.
You said Kenneth Glass is making this?
Yeah. We could make it though too in your shop. It doesn't really matter. So the actual motor itself, if you're interested in a link to that, I'll post it right now in the chat. And when you click on more details, the page doesn't open anymore. It used to open. So something broke.
Ken Glass is like a Harley guy. And Ken, my brother, was saying that the motor mount he made looks like something from Orange County Choppers. Stephen, you seem like a guy that would have a Harley.
Nope, never been bikes. My wife does though, has a Honda.
Yeah, there's not, oh, it says more details. You're saying that doesn't work, Ken?
Right. For
Yeah.
me. What else would we like from the supplier since we're talking about this? Engineering drawings. Anything else?
Yeah, they typically have your, an application drawing, like, your typical circuit. There are, components that can drive these things, like that microchip component. And that's, I think, mentioned in that video that I linked to up above. But yeah, so your typical application, I think it's called.
Okay. These guys haven't been very forthcoming or useful with questions like that. And it seems like, there's one guy in the neighborhood makes the circuit boards for the hoverboard, then his friend makes the motors, and they end up doing all their own specialties.
Right. It's kind of like these hoverboard motors have a recipe, and all they know is they're just selling, they make it according to the recipe, and the recipe standard, and they don't even know like what the detail of the recipe is. They just make the recipe. You can't find like any explanation of how the any explanation from these guys that I found, like what is the pinout for the Hall effect connector. You just have to find that. Someone else put that up on the net. Probably from reverse engineering a hoverboard.
Exactly. If you want the documentation, you got to go back to the US and find out who originally designed it.
And quite honestly, this company may not even be making these motors.
Right.
They might be made at a shop down the street. It's you never know till you go there. And then different people join the room and the discussion, and it turns out the connections are friends. And Guanji, made by Guanji, they're a very special form of relationship where I trust you, therefore you can trust my friend, and so on. So I'll ask for engineering drawings, the complete specs, and any microcontroller interfacing examples for fun. I'll hang out here for a minute or two in case we get a response before I leave, because it is morning there.
Chip, the machines you got in last week, did they hook up all right? Oh, he's on the phone.
Yeah, I can answer that. Yep, they did. Yeah, there's three-phase power brought in for a lathe and a mill. And one machine's already making parts for us.
Great, great.
I'm going to clear off. Good night, everyone.
Good night, all.
Cheerio.
Hi, Michael. I'm going to head off too. Night all.
Thanks, Euros owners. Thanks for joining us.
Cheers. Ta-ra.
And I'm going to be passing chip host. I'm getting 100 of those motors, Dave, in the first batch. And provided they're good, we'll turn around and place another order for 100 right away.
So then there'll be 2 eval connectors. So it's a dual connector to drive each motor board.
Mm-hmm.
Okay.
Yeah. 3 for the motor signals power, and then there's that encoder connection.
Right. And then a couple more for sensors, current sensors.
Right. I think it's a 6-pin connector. Does that sound right? Maybe it's ground and then 3 encoders.
Yes, that means you can do. That means using the mini breakup board, you'd have enough to power the 2 motors, but no other devices, connector-wise.
Oh, gotcha. Mm-hmm.
And that's going to be interesting. Oh, I ran into an odd need the other day. A logic analyzer breakup board for the eval connectors. Because if I want to put say a dual connector dual connector click on, I've got no way to get a logic analyzer to the pins. So you almost need to put an in-between module so you can get to the signals and measure them.
Mm-hmm.
So
John's interested in that too. He brought that similar thing up today. The
He
popularity of that $13 tool, and I'm sure he's encountered this. How do I grab the signals as well?
Well, this is where my namesake PCB is a little bit advantageous because you can connect oh yes, you even with the Johnny Mac, if you had male pin headers that you could stick into the female headers, Stephen.
Sure.
Help you. You know, and I'm sure you've got, like I do, 20 or 30 million male, female, female, male, male, male wire, you know, in your office.
Yeah, it's called be careful because you end up with nests of them.
I have boxes, and then I ended up ordering more anyway. And enough of this version. Let me order more.
You know, John, I just may do a logic analyzer breakout board so we can attach click modules to the small mini boards.
That would be useful because, you know, even again, as I for those that saw me struggle last week during my presentation when I thought my sensor failure detection code wasn't working, it was in fact the logic analyzer that was swamping the input.
Oh wow! Okay.
Propeller logic analyzer, as useful as it is, was actually fooling me. Because, you know, I was really frustrated after the meeting, and you know, I immediately hooked up another one on a different board that didn't have the logic analyzer, and it worked perfectly, of course.
Of course.
I determined that. But yeah, it is still, you know, it's probably one of the better $12 or $13 I spent on, you know, is what I paid for lunch today. I have that has actually, you know, I was telling Ken earlier that I think it was Bob, Digital Bob, one of the Bobs from the forum, you know, needed a driver for an LED, a smart LED strip that I don't have. And this is around Thanksgiving time. So I thought, well, okay, I'll look up the spec, I'll write some code, and then I'll look at the output on the logic analyzer. And it looked correct. I sent it to Bob, and he said, yep, works perfect. Thank you very much. So it's a useful tool. So, you know, to your point, especially with the clicks, because I've been working on more click code too, kind of quietly in the background. Sometimes it would be nice to just say, you know, to sneak in a logic analyzer and see what's going on with it. That might be, if I may steal some of your time, Stephen, maybe that would be a presentation, like logic analyzer for beginners.
Sure.
I'm suggesting that you do it, not me.
Well, I figured. But I might know a little bit about it since I was actually on the large-scale logic analyzer team for a number of years.
Exactly.
You might be able to get away with doing something like that. I also use IK Logic, their little $200 one, and I did buy your cheap one, John. So
it's not mine. I just happened to see it.
I know. I realize.
Yeah,
But
but
the
I
one you
have been
suggested,
talking
yeah,
to all of my friends as something, just spend the 12 bucks and throw it in your kit for an emergency.
exactly, exactly. So I have lots of logic analyzers, including, we have mixed signal oscilloscopes, which give you 16 channels of logic over the top of the
Oh, nice.
oscilloscope as well. So yeah, been around LAs for a while. Actually designed triggering software for 64 channel gigahertz stuff.
Wow.
So yeah, inside the logic analyzers.
Wait, how many gigahertz?
2 or 3 gigahertz triggering. Yeah, for 64 channels simultaneously.
Ah,
I was working with the chip designers and then doing the driver right next, coming just out of the chip as a driver for doing logic reduction and triggering. And so working with them to do, how do you specify certain types of triggers? And then I do the software side of it. So just kind of fun. Things that you wrap your head around and then years later, you don't remember a thing because it was so detailed. That kind of stuff.
yes.
Yeah. Oh, I have some interesting stats on the cube. Memory usage. Chip, your 512K made it possible. The screen buffer alone, imaging the cube, is 72 K bytes. The set of, if you run 16W PWM, each frame buffer, each PWM frame set is 192 K bytes.
And you want to
So if-
probably double buffer that.
Exactly. And so I'm at 396K for screen buffer and PWM buffers alone.
Good.
For the cube, just to let
Good.
you know. But I am able to achieve, running at a 15 megahertz clock data rate, I'm able to achieve 63 frames, full frames per second on the cube.
That's pretty good.
So that's pretty impressive. That's probably a lot more high power than you actually run than you want to run battery powered.
Oh, right. And you've had your thing going 30 megahertz before though, right?
Not for these panels. These panels are topping out at about 15.4 right now.
Okay.
I can probably figure out another way to drive them to up that speed, but I can't imagine that we need to.
No, but you could use extra cogs to drive separate data to like each panel, huh?
Yeah, but then you're broad wiring. Right now it's a twin headers to drive one stream. And so for every 2 eval headers, you could drive one chain of panels.
Okay. So you're driving 6 panels over one connector.
Correct. Correct. And so, but that's why I scared people with my 8 amps per panel, because I was running flat out, lots of full brightness stuff, trying to get the frequency as high as I could. That kind of drove power consumption.
I bet.
But kind of fun numbers. I have it working at 4 panels now. When I jump it up to 5, for some reason, I'm accessing memory badly. And so I've got a math problem somewhere in my driver. So I'm chasing that down now, but 5 and 6 panels are next.
Good.
4 are working beautifully.
Super. Did Jonathan Shook ever come back?
He's been online periodically and chatting with us. You'll see it in the P2Q. But I think he's still distracted by another life, another project yet for a little bit. I don't know whether it's home stuff or actual paid work or what. But
right.
Yeah, it's been good to have him participating in the forums.
Yes.
But
Hey,
I
someone
have.
had asked.
Go
Go
ahead.
ahead.
Well, I was just going to say one last thing. I have one user in the P2 Cube forum that has actually started assembling and is literally camped on my getting 5 and 6 panels. He says, "How am I doing this?" I said, "Wait, you're ahead of me."
Oh boy.
So kind of fun.
Someone had asked about the machines here. I don't know if they're still on the meeting. Was it Carol maybe? Had to do with a CNC question, something about CNC machines. Maybe not. The call I took was from my neighbor. I have this old Mitsubishi pickup I really want to get rid of, but it's probably not going to pass smog. It's an old carbureted, it's a 1988. And it's really hard to get rid of these things because of the DMV.
Oh, right.
And all the registration that's lapsed, and it's just sat here. I was just going to use it on the property, but now it just kind of collects dust. But it's hard to unload something like this. So he took everything to the DMV and was trying to get to the bottom of it, but it's all indeterminate. They can't tell you what it's going to cost to register until you initiate the process.
Hey, Chip.
It's like the hospital. Yeah.
Go down to Arizona, $70 for 2 years. Done. Then bring it back to California and re-register it, and you got no problem.
Oh, interesting.
I have an old Toyota truck that sat and lapsed for like 10 years, and they wanted like $3,500 to register it.
Oh gosh. Yep.
$70 in Arizona. Brought it back 6 months later, registered in California. It was done.
Yeah. Yeah. I'm only asking $800 for this pickup, but the government can make it cost 3 times that.
Yeah, and the seller's responsible.
Yeah. Yep.
Welcome to Commie, California.
Exactly. I have a really nice Hobart mixer I rebuilt. It's a 30-quart mixer, and I put all new bearings and seals in it and completely rebuilt it. And it's like it survived everything but the OSHA regulations. But it's a good mixer, but it doesn't have all the guards in place like the new models do.
I heard, babe. Oh. Excuse me. I was answering my wife. That was great. Sorry, guys.
No problem.
Okay, so I'm going to head out. See you all.
Thanks for your presentation. Interesting.
Hey, Michael's back. Michael, what have you been up to?
Concrete. I'm moving 56 bags of concrete and 60 bags of soil to extend my garden. I'm moving heavy stuff and I'm getting too old for this.
This isn't concrete bags that sat out in the rain, is it?
Yeah, I have to get them moved before it starts raining, and it's supposed. I heard about rain next weekend. I don't think so, but no, I have to move it before it kind of gets. Yeah, but I'm getting too old to carry that shit, you know. I start with a lie. On the corner of that concrete bag is standing 60 pounds, easy to handle. Aren't. Well, not easy to handle. After the first 9 ones, you are getting tired.
Yes.
No, currently I'm kind of building my garden. I have to get the garden bigger, and I still need to kind of find somebody to cut the wood I bought from you. It's nice wood, but it is too heavy for my machinery.
Yeah. It looks like you have some room behind you where you could put a saw.
I have the space, yeah.
Michael came up, was it last week, Thursday?
Friday, Thursday, something new.
Friday. He bought some of this walnut wood I cut 12 years ago. He was the least picky customer ever. He just took the first 13 pieces he came in contact with. Usually people are looking for certain dimensions and they want they want to inspect every piece. But he just grabbed the first 13 pieces.
It's nice wood. I mean, yeah, it is. You can make everything. I mean, I wish I had the money to get the rest of it. I'm honestly thinking about it. I mean, the price you offered me, 15, is not that bad. I mean, it's no. I'm not sure yet.
Yeah, I'm trying to unload stuff. See, if you look out here, see how nice and bright the shop is? I got up on the roof and I replaced all the skylight panels. There are 6 of them. Now it's daytime in the shop. It used to be kind of like always dusk. But I just want to get all this stuff. I got too much junk right now. I want to get rid of that pickup. I've got all this wood left over that I cut and some big woodworking machines that I don't need if I don't have the wood. And I've got like 1,500 sprinkler assemblies I don't need.
Sprinklers. Interesting. I might need some of them for my garden.
Yeah.
I have to come up there again. Shoot.
So usually here, if there's stuff of no value, we live on a highway. I just move it out to the road and put the free sign on it, and someone comes by in like an hour and it's gone. I had to finally make a really ugly free sign because they kept taking the free sign with whatever was out there.
Actually, you have to put $10 on it because then it moves faster.
Yeah, I think only the $10 might move. One
No,
time
but
I had
honestly,
this.
I looked at that wood the last 2 days. I was kind of moving shit around here, and every time I sat down, I looked at the wood, and it is really beautiful wood you have there.
Yeah.
It would be a shame. Yeah. I mean, I'm thinking if I probably rent a trailer, something. I have tons of ideas I could make out of this wood, but actually I don't really need it.
I know, you need wood like you need a microcontroller.
Yeah, exactly, and I buy them also. Somehow it's that parallax thing. I don't know. Yeah, but if anyone is interested in black walnut, honestly, this stuff Chip has is awesome. Awesome wood.
Yeah, I was really, it is cool. See, I didn't want it to go to waste. So when we took out that really big orchard in back with these old Franquette trees, they were 60 years old. I had these guys come out and mill it all and we put it in the shop. But now I'm down to the tailings of it. And my love affair with the wood is kind of over. Michael's is just beginning.
Yeah, it does. Yeah. No, it is, I like wood. The last couple of weeks I was working with metal. A friend of mine, like you, has a stack of wood. He has a stack of those C-shaped metal bars, kind of tin, metal with tin on it.
Yeah, channel iron.
Yeah, and you can build shelves out of it and stuff like that, So the last couple of weeks I'm working with that metal, and gosh, metal is so unforgivable, You make one fucking stupid mistake and you can't stretch it, With wood you always can kind of, come on, But metal is unforgivable. Mistakes there needs cut again, Mike, So I already built kind of.
Oh, you can, but you could use a welder to fill back in.
Yeah, okay, I do. Yeah, I mean, I have a welder and all that stuff. It's just metal is less forgivable than wood, and I like more to work with wood, because I tend to make mistakes. I'm pretty good at that, actually. But you are learning, learning by doing. That's the way it is. Oh. So, guys, one thing I have a problem with is that I need to build a motor controller for those electric cars of a friend of mine, and they are actually using some microchip ST65 something 8-bit controller. And I haven't figured really out what they are doing, but I need to replace the whole controller thing, and I need probably advice. I will start a new thread about it, but I will need to have advice to run DC motors up to 450 volts. It's about cars. Currently, they're running at 220 something, and yeah, they kind of lack the power they need. The company is called Corbin. If you Google Corbin 3-wheelers electric, you will find them. Corbin 3-wheelers. I basically bought together with a friend of mine all the companies. They stopped producing in 2004, and now we have all the cars and all the parts and stacked up, and need to get them running. And those motor controllers are also from 2004, and I mean you can get the chip, but it's
yeah, because the conduction of FETs has improved quite a bit in the last decade.
Exactly, yeah.
So these days you could get something much smaller and cheaper.
Yeah, my plan is basically to build a new motor controller instead of getting those old EEPROM. There are ST microchip, I don't know, 65T25C6 or whatever. It's kind of an EEPROM and a 8-bit controller and one 28-pin chip. And those things are rare. I mean, you can get those chips, but the programmers for the chips are $1,200 or something like that,
Yeah.
So I'm thinking about replacing it through something else. Or just build a fucking new controller. Which I probably would prefer. Peter is not happy because he has 30 of those old ones sitting around. But I think it's better to build new ones instead of refurbishing the old ones.
Yeah, I'm thinking about this motor here. It's
that hoverboard thing.
Yeah, it's got some imperfections, right? It's designed. I mean, it has some manufacturing tolerance, which makes every relative position different as the motor turns around. It's not perfect. It's like there's a little bit of like irregularity within a single revolution. But you know what? If you could actually use some code to map out the motor and know how to drive it.
Look up table.
You learn its imperfections so that you keep track of like where you are within the revolution, and you know exactly. You could take a wonky motor and make it run real smoothly.
Chip.
Yes.
I believe that was Erna, Erna from German or something in the forum that said wrote in a thread. Sometimes it's better to you to run your motor through a power tool and observe the waveforms first. Then you can learn how your motor is, in fact, before you try to control it. Sure, that type of setup doesn't keep with some imperfections due to current, because if you have too many imperfections into the coils, you've got a lot of imperfections when you try to run that motor. But for the waveforms, for the basic waveforms, and the ones you were telling about, it's just will appear when you run your motor through a power tool. So you can observe and grab a lot of data before you try to control it.
Yes. Yeah, that makes sense because, you know, the permanent magnets go around the hub in this case, and then the electromagnets are stationary, but they're not all completely consistent. There's like a personality to all this. So if you turn the motor, you're going to see like you could it makes some sort of auto correlation algorithm that would figure out what phases overlap, you know, what constitutes a revolution and where does it repeat. And then you could probably drive the motor at least probably more efficiently and also more quietly.
Yeah.
Because you have some difference into the magnets too. So the way the magnets, the fixed magnets interacts with the coils determine the waveforms you observe. So you must turn the motor until a complete electrical revolution and mechanical revolution at least, but you
need a whole
more data.
Yeah, the mechanical revolution sets the overall period.
Yes, but there are motors that are intentionally made to need more than one mechanical revolution. When you start, I don't remember exactly where I show, whether I did see that, but there is a guy, I believe I posted the YouTube channel for that guy that does a lot of experiences with those kind of motors, and you can see, because you can see the holes into the motor shield, that the alignment of the magnets to the windings will slightly vary when you turn the motor until you complete the same positioning again. Because for example, one have 48 magnets and 47 magnets and 48 poles in the sense of the arrangement of the three coils. So it's strange, it's weird, because you notice that is a lot of possibilities. The last time I deal with those matters was in 1987 with IBM. Yes, with IBM Capstan motors for the tape drivers. And those motors consumes huge amounts of current from a 48 volts power supply, about 13 kilos or more the power supply with a huge transformer. And the current peaks are amazingly high because the motor was made from
itself.
Yes, it was made from ceramics. Those motors were made from ceramics, and the coils were made from flat circuits. So the inertia, both magnetic and mechanic, are very, very, very clean. They can turn and they can reverse. Because I didn't saw ship reverse in his motor. When you reverse the motor, he almost reacts instantly because the inertia is so low into the rotating mass. It's very, very fantastic. And this is a technology from 1975.
Wow.
Way back, almost 50 years back. It's weird. It's amazing.
Yeah, we need to kind of figure out that backfeed thing, that measurement, that we can measure the other coils while pushing some, so we can get the feedback more relying on what's really happening. And I think the P2 can do that. We can basically with the second pin check the current. I'm thinking about that currently. The motor controller, I mean, what they do now is they cost $700 and they are not really working efficient. I'm unhappy. I want to replace them, and Peter wants to keep them, but I want to replace them. So I need to build a demo controller, and I might need some help there. But I think P2 should be a perfect motion controller for, I mean, because you have that ability to do that neighboring pin thing and kind of put a second smart pin to monitor what really happens. I think that will be the breakthrough. It's just that I don't really understand those motors yet.
Yeah, they have personalities. Look at this. I've got this one now reversing.
Yeah.
I just added to the code. And the current jumps up when it turns around.
Yeah, sure. I mean, that's normal. Yeah, but the point is to get them running slowly is way more difficult than run them fast, you know.
Chip.
Yes.
I believe you need to observe the voltage and current spikes so you can match the turning back with the spikes that the coils will blast when undriving, like a relay.
The back feed, yeah.
Yeah, the freewheeling pulse can be observed. So you need to understand when the coil get this de-energized. It's a way to avoid the simultaneous current spikes from the different turning rotation and the back EMF from the motor.
Exactly, yeah. That's what I'm thinking too with the motors, because this is about three-wheeled electric cars. I have currently about, I don't know, 18 of them to fix, you know. And I think that the old controller is way too energy hungry because it doesn't check on those overcurrent moments.
Yes.
Yeah.
I believe the work that Erna linked at the chat from one student of Germany, I believe, that Erna said that he refused to work with the Prop 2, the Propeller 2. Erna did try to attract his attention to the Propeller, but the guy now is thinking about video and doesn't think about BLDC motors anymore. So Erna wasn't able to attract his attention to the Propeller 2.
Yeah, Erna put a couple of posts out there about how to calculate those things, and I have to admit I just understand half of what he was writing. But he basically, I think he knows exactly where we are at that point to reading kind of the other coils while you are powering one of them, and then get basically feedback from the motor without having any sensors on it. And I think what he is doing there seems to be possible. It's just a mathematical problem, in my opinion. But I think it's possible.
The most likely you can, oh, excuse me. The most likely you can control the motors like a PLL loop. The most likely they will turn smoothly and without torque, skipping the torque too much. So they will turn very, very smoothly, even under heavy loads. So Chip, you can try to hold the wheels with your hands when the motor is changing direction, so you can observe the differences in currents and the spikes into the circuits with your scope to get a meaning about the way the circuit will be reacting underloading conditions.
Yes.
Without only with the load of the wheel, we will have almost only the wheel as an inertial object. When you try to hold the wheel with your hands, we will observe a totally different behavior, because now the current spikes will be way higher to keep with the new torque needs.
Right. And my problem is like what Chip is describing, and is that the existing motor controller has problems with driving the wheels in slow speeds. Works perfect if you run it at highway speed, but it doesn't really work in slow speeds.
But with the Hall effect sensor, you can control it really slowly, but you have to turn it a 90th of a revolution, because there's 15 like electrical revolutions per mechanical revolution. And each one of those is divided into 6 pieces. So 6 times 15 is 90. So this motor senses a 90th of a turn.
4 degrees.
It's about 4 degrees.
Yeah, that would be 4 degrees, wouldn't it? Yeah, 4 degrees.
Amazing.
Yeah,
Amazing.
I believe that kind of cannibal.
This is why a PLL behavior of the control loop can get you where you want, because even those 4 degrees can be splitted into smaller divisions if your PLL loop can keep with the actual rotation of the motor. So you can split those 4 degrees even in 10 parts or 16 or whichever you want. And then you have the most precisely control over the motor. That's the trick. That's the real trick. Using all the resources.
And then you also reduce the power it needs, because
and also the torque jitter, because when you try to switch a coil far from the point the motor is, greater the torque glitch will occur, because the angular difference is too much, and possibly depending of the loading conditions, possibly there is a span where the motor will not react accordingly, because the winding you are switching is far from the point you need it to be. So there is more than 8 points, switching. You can switch with smaller increments in voltage, and not all control circuits are able to do that. Normally, they only split the maximum power through the power transistors, and don't control smoothly exactly where you want to put the coils aligned to the magnets.
Right. Right, exactly.
I have a lot of
I think
difficulty.
when we can use the second smart pin to measure the current,
Not only the
we
current,
could be able to find that sweet spot. You know, it's. I think it's just a software problem, sort of. You know, if you can.
yes,
Yeah,
mostly,
yeah.
you are right. Because you are not seeing only the spikes for the when you are trying to move the motor, sensing by the Hall sensors, you can check that you have a spike from of current due to the transistor being switched, and you also have some information about the just the coils that are just into freewheeling.
Right.
Because
Right,
yes,
right,
yes,
right.
there is. So you need to split the interference from one with another before you get a meaning exactly where you are into the rotation.
Exactly. Yeah. And I try to figure that out with that lovely debug screens Chip provides. I'm getting used to those screens, Chip. They're really cool. You can visualize things. You know? No, that was a very bright idea of you. The whole debug thing.
I was thinking of that back in '96 when we did the SX chip, you know, making some kind of set of visualizers. But I should have done it back then, but took me forever.
Yeah, what is new?
Right.
Ask
Right.
Ken. Oh, 10
Guys,
years. Okay.
I've got to get going because I got to go up to see one of our kids is in a track meet and I got to drive a half hour. Now I leave. Do any of you want to be the host?
I'm fine. I have to go into my garden also, so carry some more concrete bags. We haven't done
You need
any
a tractor.
Yeah.
You need a tractor, Michael. I posted a link to a small tractor that really can help, but I don't know the price.
Yeah, Chip has one John Deere sitting there getting dusty.
Oh no, I used it today. I sprayed all the apricot rows.
I did, yeah. So it's not useless, yeah. No, but it's a nice one. I like those old.
No, it's
I
not.
like old stuff, yeah.
Chip.
Yeah.
Just before you leave,
Yes.
only not a question, but I beg you if you can put something about the comparator feedback, not feedback, but hysteresis voltage embodied. If there are any 6 millivolts or something of hysteresis built inside the actual comparators.
Not intentionally. I'm sure there's some that exists, but I've never measured it and I didn't design it to have any intentional hysteresis.
It needs to be something because I was trying to study, but I believe no one understood what I was meaning, and I wasn't able to draw a diagram because I was installing my washing machine the past days, and that took me a lot of time to rearrange the things into the kitchen to fit the washing machine that is huge. But I was thinking about using, for example, the 150K ohms resistor, one for pull up and the other for pull down. So you can be centering the measurement within 1.65 volts into the input of the comparator. And if you trade one side, for example, the high side you can will be conducting almost 11 microamps when you use, or no, 1 microamp. 1 microamp when you are using the, 11 microamps when you are using the 150 k ohms. But you can trade one branch with a 10 microamps source control through the system of analog switches that you embodied into the diagrams. I'm not sure that I can do it, because then we have a 10% difference. I was using some calculations into the net and Norton, I believe the Norton currents. And if you trade one resistor, or the upside or the low side for a nearby current source, you can vary the 3 point, the center point, about 10% way down or up. So you can have at least, it's too much, I believe, too much of hysteresis, but it's better than no hysteresis at all.
Right.
I don't know if we can program the muxes to simultaneously have 150k ohms to the 3 volts and 150k to the ground. Then switch one of them, then switch only one of them and trade for a current source for the input of the comparator.
Yeah, well, you should be able to do that. I mean, you can set the high and the low drive, and it will compare pin A to pin B, and then you can select the input mode. So it'd be 0111 underscore, then you have the clock, CIOHHHLLL. You can set those however you want. You could build all kinds of op-amp type things out of this. Not all kinds, but well.
Yeah, yes. It's very flexible. So I believe that's a way to have some hysteresis, and you can control the amount of change into the sense voltage because you can control the resistors that are in series with the signal being sampled at the same time. So we have a lot of possibilities there that we can trade one for the other until you reach the most likely sweet spot.
Should be like that, yes. If Chip did everything right, it should be, yeah.
Yeah. Okay, well, hey, I should go, but does anyone want to take the meeting over? I can assign anybody who wants to hang on and run the.
No, I'm quitting out also. I have to move stuff, but good to see you again.
Okay, guys.
Next Wednesday. All right.
Okay, good to see all of you, and thanks for all your help with everything.
Oh, we are getting you. We are doing this. We are all addicted. No, it's kind of addiction.
Yeah.
See you then. I'm shutting out here.
Okay, guys. All right. Well, the rest of you take care, and hopefully we'll see you in a week.
Bye for you.
All right. Bye, Enrique. Bye, Greg, David, Edgardo, Jim, Joseph, Robert, Samuel, and Greg.